Hi, fifth graders. Today we're going to talk about elapsed time and how we can convert units of time. So a couple quick refreshers. These references you are expected to know. So you are expected to remember that there are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week, 52 weeks in a year, 12 months in a year, and 365 days in a year. If there are any that fifth graders have had trouble with in the past, it's that there are 52 weeks in a year. So if you have never seen that conversion before, you might want to put a little star next to it because it will not show up on your reference sheet. Now, you're also going to be expected to know that sometimes you'll see minutes represented as a fractional part of an hour. For example, 1/4 of an hour is the same thing as 15 minutes. In word form, you might read this as quarter after. A half an hour is the same as 30 minutes. You might see this written as half past. And 3/4 of an hour is 45 minutes. You might see that as quarter of or quarter to the next full hour. For example, I'm recording this video at 3:45, which means that there's only 1/4 or 15 minutes left until the next hour, 4 o'clock. Finally, AM and PM. Now you might be thinking, well, duh, AM is morning and PM is afternoon. But these are also really important because AM and PM are our units when we're working with time. So when you find the numbers that match your answer, you also have to remember to write whether it's happening in the morning, AM, or in the afternoon, PM. Okay, so now that we've freshed our memories on that, let's talk about 3 different kinds of problems we might see. You might see questions where we have to move into the future or find an ending time. You might see that we need to find the elapsed or the amount of time in between. Or you might see that we need to move backwards in time, meaning we know the ending time, but we have to find the start. In any of these kinds of problems, you can solve using a number line or a T-chart, and I'm going to show you an example of each for each of the different types of problems. You can use benchmark or friendly numbers to help make your addition or subtraction a little bit easier. And before you do anything else, turn your fractional parts of an hour into hours in minutes. So for example, if you see 3.5 hours, you should write down that that means the same as 3 hours and 30 minutes. And if you see 2 3/4 hours, you should mark that down as 2 hours and 45 minutes. Okay, let's take a look at an example of each of the 3 types. First, we're going to look at a question that needs to move into the future. This one says, Monica spends 2.5 hours working on her computer. If she started working at 10:30 a.m., what time did Monica stop working? So first, let's change 2.5 hours into hours and minutes. I know that means that it's 2 full hours and an extra 30 minutes that Monica was working. Okay, so let's look at our number line strategy first. In this question, we know the starting time, so I'm going to put a point for our starting time of 10:30 a.m. And I'm going to draw loops on my number line to move forward until I get to the ending time. A lot of times I like to start with the biggest chunks first. So I'll add 1 hour, which gets me to 11:30 a.m. And then I'll add a second hour, which gets me to 12:30 p.m. I know I'm in the p.m. now because I'm later than noon, so that's why my unit changed. So now I've used the 2 hours, I also need to use the 30 minutes. I'll add 30 minutes, which brings me to 1 p.m. That tells me that Monica finished at 1 o'clock in the afternoon. I can also use a T-chart to help me with that. So if I'm starting at 10:30, let me add an hour. That brings me to the 11:30 a.m. time. I'll add a second hour, which will bring me to 12:30 p.m. And finally, I'll add those last 30 minutes, which also tells me that I ended at 1 o'clock. Let's take a look at a second type of question. This is one where we need to find the elapsed time in between. Let's look at a number line again. This time, I know that my starting time was 7:41 p.m. and my ending time was 8:50. Here's where I can use some of those friendly or benchmark numbers to help me. First, I'll move forward in time 1 hour because I know that I have at least 1 hour between 7:41 and 8:50. 1 hour later than 7:41 is 8:41 p.m. Now you might see right away exactly the number of minutes you need to jump. So in the number line example, I'm just going to jump right to 8:50 by adding 9 minutes. That tells me that the elapsed time was 1 hour and 9 minutes. We can also use a T-chart with these kinds of questions. My T-chart is going to look slightly different than my number line because I want to show you another way you can use those friendly numbers. So again, I'm still going to start at 7:41, and I'm still going to add an hour as my first jump. That means I have 8:41 p.m. Now, maybe I didn't recognize that the difference from 8:41 to 8:50 was 9 minutes. I can use friendly numbers, and usually those are numbers that help us get to a 5 or a 0. So if I add 4 minutes, that brings me to 8:45. Then I can add 5 minutes, which will bring me to 8:50. And finally, I'll add 1 more minute, which will bring me to 8:51. This still all adds together to be 1 hour and 9 minutes. So no matter which jumps you see, as long as you end at the correct time, you'll have the right amount of elapsed time in between. Our third type of question is one where we need to move backwards in time. So for example, you might see a story problem like this. Robert's soccer team needs to be off the soccer field by 12:15 p.m. Each game is at most 1 3/4 hours long. What time should the game begin to be sure that the team finishes on time? So first, let's change that 1 3/4 to hours and minutes. I know that's the same as 1 hour and 45 minutes. So if I use a number line, now I know the ending time. The ending time was 12:15 p.m. So I'm going to work backwards to find the time that the game should start. First, I'm going to go backwards by 15 minutes because this is a friendly benchmark number that helps me get to an even hour. That means that it gets me back to 12 p.m. or 12 noon. Now I could jump back a full hour. That brings me back to 11 a.m. But the games aren't just 1 hour and 15 minutes, they're an hour and 45 minutes, which means I still have to move backwards another 30 minutes. That means Robert's team should start the game by at least 10:30 in the morning. Finally, let's look at a T-chart strategy for this question. Again, I can use those friendly numbers, but I'm going to use them slightly differently. This time, I'll start with an ending time of 12:15. I'll take those 15 minutes off right away. That will bring me back to noon. Now, let me get rid of the other 30 minutes. If I move backwards 30 minutes, that brings me back to 11:30 a.m. Now I've used all 45 of those minutes at once, so the last jump I need to make is to move back 1 hour. Either way, I still have a starting time of 10:30 a.m. as the time that Robert's team should start. So no matter which strategy you choose and which type of question you have, when you're converting elapsed time, go carefully, make sure you change any of those fractional values into hours and minutes, and use those AM and PM units whenever you need them. Thanks for tuning in, everyone.